Hello everyone, I am Chandras Mishra from ABES Engineering College, Ghaziabad. In this lecture, I am going to discuss Floyd Warshall algorithm to find all pair shortest path. Here we'll see all pair shortest path, then we'll discuss Warshall algorithm and then complexity of the algorithm. So let's begin with all pair shortest path. So whenever a graph is given, then we need to find out the shortest distance, or we can say the shortest path between each pair of vertex. So let's have an example of the graph. So this is the graph. This is the graph. Now let's say these are vertices A, B, C, D, and E, and there are some weight associated with each edges. Like this is 2, 1, and this is 3. This is again 1, and this is 2, and this is 3, and this is 1. Now we want to find out the shortest path between each pair of vertex. Like we want to find out what is the path for A to B, A to D, then A to C, then B to C, then D to C, then C to E. Like this, we want to, and so on. We want to find out all the paths. So if we take two vertex like A and E, and we need to find out path. So there are multiple paths possible between two pair of vertex. So if you take A and E vertex, so here path are we can move from A to B and then B to E. And the cost associated with this is 2 and 1, that is 3. If we take another path like A to D, then D to C, and then C to E. So this is also one path, possible path, A to D, then D to C, and from C to E. Now the cost associated with A to D is 1. D to C, suppose this one is also 1. So D to C is 1 and C to E is 3. So total cost is like 5. So like this, another path is from A to D and D to B and B to E. This is also one path. We can take like A to D and then D to B. Then from B to, we can directly go to E. So A to D is 1 and D to B is D to, if we are going from D to B, it is taking 3. And then from B to E, it is taking 1. So cost is again 5. So there are multiple paths available between these pair of vertices, but the minimum one is, the shortest one is 3. So like this, our goal is to find out all pair shortest path, like shortest path between each pair of vertex. So for this, we have a very good algorithm, that is Warshall's algorithm. We'll see here what is Warshall's algorithm to find out all pair shortest path. So basically, Warshall's algorithm work on the concept of intermediate node. It means if there one by one, if we take each vertex as the intermediate node, and we try to find out whether this shortest path exists on which vertex. So there are 4 vertex, like 1, 2, 3, and 4. So first we'll keep 1 as the intermediate vertex, then 2 as the intermediate vertex, then 3 as the intermediate vertex, and 4. So all vertices will act as intermediate node, and we'll find out which one is giving shortest path. So basically, this is the process of finding all possibilities. And this is the dynamic programming approach, basically, we can say. So here we have weight matrix. Suppose weight matrix is given to here, or we can say adjacency matrix of the graph is given. There are n rows in that adjacency matrix. It means there are n vertices. So here D0 is denoting direct, that is adjacency matrix. This is the adjacency matrix of the graph. It means in this we are having direct edge. If there is direct edge between a pair of vertex, then the weight is written there. After that, we have outer loop which will run k times, and k is the number of vertex. Okay. So basically, what we are doing, we are making each vertex as the intermediate node. Suppose vertex 1 is the intermediate node, and then we will find out the distance of all pair of vertex. After that, we'll make 2 as the intermediate node, and then we'll find out. And how to find out the cost of that node if we make that node as intermediate node? So for that, here we have a formula Dij k equals to minimum of Dij k minus 1 and Dik k minus 1 plus Dkj k minus 1. So what is the meaning of this line? Basically, we are saying that if k is the intermediate node and we are trying to find out the distance between I to j, so we'll keep I to k and then k to j. So the distance between I to k and k to j, if we'll add, that will be the distance from I to j. So what we'll do, we'll just compare this distance I to k and k to j, ik plus kj, with the existing distance of dij. If the current, if the existing distance is less than the newly computed value, that is ik and kj, then definitely we will not change it. If the new value, that is ik plus kj, is less than the existing value, then we will update that value that way. And we will do this for n time, where n is the number of vertex in the graph. So this formula is very important. So why we have written this k minus 1? Because we are taking value from the previous one. We are going to calculate the distance for the kth matrix. That is, whenever we are making k as the intermediate node, we will keep the value of k minus 1. That is the previous vertex that was considered as intermediate node, to find out the value. So let's begin with an example, and then we will do step by step. Suppose this is the graph given here. Here we have 4 vertex, 1, 1, 2, 3, 4, and there are some weights assigned on these edges. And we are trying to find out, we are going to find out all pair shortest path. So first of all, we have to find out the adjacency matrix of this graph, that is also called D0. So let's say the adjacency matrix of this graph will be, so let me write vertex number 1, 2, 3, and 4, because here we have 4 vertices, so there will be 4 rows in the matrix and 4 columns. So what we'll do, we'll just try to find out the edge between pair of vertex. If there is an edge, we will put the weight associated with that edge. If there is no direct edge, we will put infinity at that edge. Simple. So we can see here there is no self loop, so we'll just fill all diagonal as 0, all diagonals as 0, because there is no self loop in this graph. It is very simple directed graph. And if we take this one, so if we take 1 to 2, so 1 to 2, is there any path? Yes, direct edge is there, and the weight is 3. So we'll just put 3 here. 1 to 3, 1 to 3, no. So we'll put infinity. 1 to 4, is there any? 1 to 4, yes. and the cost is 5. Then come to 2. What is 2? 2 to 1. Is there any path? Yes. This is the path and the weight is 2. So we'll write 2. 2 to 3. 2 to 3. Is there any path? No. No direct path. So we'll just put infinity here. 2 to 4. Yes. This one. And the cost is 4. So we'll write 4 here. 3 to 1. So 3 to 1. No. There is no direct path. So we'll just put infinity here. 3 to 2. 3 to 2, yes, this is the path and the cost is 1. So we'll just write 1 here. 3 to 4, 3 to 4, no path. So we'll just write infinity here. Again, come to vertex 4. Now come to 4. Is there any direct is from 4 to 1? No. So just put infinity here. 4 to 2, 4 to 2, any direct path? No. So put infinity here. 4 to 3, 4 to 3, yes, this is the path and the weight is 2. So we'll write 2 here. Now this is our D0 ready with us. D0 is ready. Now we are going to run the first pass. In the first pass, we will consider this vertex 1 as intermediate node. So what we'll do, we'll calculate D1. So let me write D1. So this is the D1. We are going to calculate. This is D1. Let me write vertex 1, 2, 3, 4. 1, 2, 3, 4. Now here we can say we are taking 1 as the intermediate node. So from 1 to 1 for all we are just copying all first row and first column. There will be no change. So we'll just copy this value from this one. So 0 to infinity and infinity, and here 3 infinity and 5. Now diagonals will fill up 0 0 0, and now first value we are trying to find out d. So here we are going to find out d23 d23 in which one, when 1 is the intermediate node. D23 1 equals to, according to formula, we are going to find out the minimum of D23 in the 0 1, in the 0th, that is in the D0, and the distance of D, because we are taking 1 as the intermediate node, so 2 1 plus D of 1 3 in the 0 D0. We'll see this value. Why we are taking this? Because we are going to find out 2 to 3, and 1 is the intermediate node. So if there is 2 to 1, there is the path from 2 to 1, that is the cost associated with 2 to 1, and 1 to 3. So if you add these values, C1 C2 C1 plus C2 C1 plus C2 is the value of D21 and plus D23. So if this C1 plus C2, that is the cost, is less than this D23, then definitely we will update the value. So let us find. So the cost of D23 that is existing is we can see in this one. D23 is infinity. Now we are going to calculate D21 and D13. So D21 is 2. So that is 2. Yeah, this is 2. We'll write 2 here. And 1 3 will see 1 3. So 1 3 is t1 3 is that is infinity. So we'll write infinity here. So 2 plus infinity, if we are calculating this 2 plus infinity, it will be infinity. Okay. So we'll just write t23 as infinity here. There is no change. Now come to d24. So to find out d24, we have to find out 2 to 1 and 1 to 4. So let us see 2 to 1, that is 2, and 1 to 4, that is 5. So we'll update. Now the value is 7. And the existing value of t24 is 4. It means we'll not update this value because we are having already minimum shortest value for this. So d24 will be 4 as it is. There is no change. Now come to 32. We are going to find out d32. So for d32, we'll take 3 1 and 1 2. So 3 1. See here, 3 1 is infinity. 3 1 is infinity, and 1 2 is 0. So it is again infinity. So we'll not update. 3 2 value is already 1, so we'll write 1. Now come to 3 4. So if we calculate 3 4, let me write here 3 4. So for 3 4, we will take 3 1 and 1 4. So 3 1 is infinity, and 1 4 is 5. So this will again first infinity. So it is again infinity. There is no change. Now come to 4 2. Value for 4 2. So 4 to 1 and then 1 to 2. So cost of 4 to 1 is infinity, and 1 to 2 is 1 to 2 is 3. So again it is infinity. So it is infinity here. So now come to value for 4 3. So for this one, 4 to 1 and 1 to 3. So 4 to 1 is again infinity, and 1 to 3 is 1 to 3 is infinity. So again cost is infinity. So here we have infinity. There's no change in this value. Now here we have t1. So we can see here there is no change in d0 and for t 4 3. For 4 3, we have already the minimum value, that is 2. So we'll not update this. So for this one, so here we'll write in 2, because we already have 4 3 2 here. Okay. So after this, we have d1. Now come to d2. It means if we are making 2 as the intermediate node. Okay. So that is right here the values. We'll just copy this value. So let us take d1 as the reference. D1. So values of the D1 are we have 1, 2, 3, 4, 1, 2, 3, 4, and we'll fill out this diagonal as it is. And now the values of 1 to 2 is 3. 1 to 3 is infinity. 1 to 4 is 5. 2, 1 as 2. 2, 3 as infinity here. Then 2, 4 is 4. And 3, 1. We have 3, 3, 1 is infinity because we don't have direct path. Then 3, 2 is 1. Then 3, 4 is also infinity. 4, 1 is 2. And then let us take this. In this D0, the 4, 1, 4, 1 is infinity. Sorry, infinity is there. So we just put 4, 1 as infinity here also. Just put 4, 1 as the infinity. Because we don't have any path, direct path from 4 to 1. So 4, 1 is infinity. Now come to 4, 2. 4, 2, is there any direct path? No, so infinity. 4, 3, we have path. So like this. So we have D1. Now we are going to calculate D2 because we are considering vertex 2 as the intermediate. So let us calculate D2. So suppose we are going to find out D2 here. Let me write vertex 1, 2, 3, 4. 1, 2, 3, 4. And what we'll do, we'll just, if we are taking 2 as the intermediate node, we'll just copy all the values of second row and second column. So basically, we'll just place this value as it is. We'll just copy this one. Okay, so let me copy it. 3, 0, 1, and infinity. And now second row is 2, infinity, and 4. Now we are going, and diagonal is already 0. So we'll just put diagonal as 0 because we don't have any path for this. Now let us try to find out the values for 3, 4. That is, let me write here 3, 4. We are going to find out, sorry, 1, 3, 1, 4, 1, 3, 1, 4. And for this one, 3, 1, D2, 3, 1. And then D2, 3, 4, D2, 3, 4, then D2, 4, 1, D2, 4, 1, and then D2, 4, 3, D2, 4, 3. Now we need to calculate these values. Okay. So here we'll write 1, 2, because 2, in this one, we will take 2 as the intermediate node. So for this, D1 to 2, and then 1 to 3. This one is 1 to 2 and 2 to 4. For this one, 3 to 2 and 2 to 1. Again, for this, we'll take 3 to 2 and 2 to 4. Here, 4, 2, 2, and 1 is the last. Here we have 4 to 2, and then 2 to 3. So we need to calculate these distance and compare with the existing one. If the existing one is minimum, then we will not update the weights. Okay, so let us see, and we'll see all these values in D1. So 1 to 2 we have 3. So we'll just write 1 to 2 as the 3 cost, and 2 to 3. 2 to 3 is infinity, so it will again infinity. Now 1 to 2, we can see 1 to 2 is again 3. So we'll write 3 here, and 2 to 4. 2 to 4 is 4, so we'll write 4. So 3 plus 4, that is 7. But at 1, 4, what is the value at 1, 4? Let me see here. So 1, 4 is already having 5. So will not update this value. So will not change this. So we'll just write at 145. So there is no change. Now come to 3 1, 3 2, and 2 1. So 3 2, cost of 3 2 is 1, and 2 1 is 2. So 1 plus 2. We can see here 3 2, that is 1, 3 2 1, and 2 1, that is 2. So 1 plus 2, that is 3. So 3 1 as 2. So here you can see in the 3 1 we have infinity, but the newly computed value is 3. So this is the minimum. So we'll update at the place of 3 1. We'll write this 3. Now come to 3 4. So cost of 3 2. So see here 3 2 is 1, and 2 4. 2 4 is 5. So 2 4 is 4. So the value is 5. So 3 4, at 3 4, if we see what is the cost at 3 4. So 3 4 is infinity, but we have 5 here computed. This is minimum, less than infinity. So we'll write 5 here. These steps are very important, so do it carefully. Now come to 4 1. So for 4 1, we need to calculate 4 to 2. So 4 2 is infinity, and 2 1 is 2. So in 2 plus infinity, that is infinity. 4 1 is infinity, and already we have infinity, so we'll keep it. Now come to 4 3. So cost of 4 2. So 4 2 is again infinity, and 2 3. 2 3 is also infinity, so that is infinity. And the cost of 4 3 is already 2. So we'll not update this. We'll keep the existing value because that is minimum. Okay. So now this is the D2. Okay. Now we'll again compute D3. It means 3 as the intermediate vertex. Okay. So now let us move to next pass. That is D3. So, which means we are going to calculate the shortest distance if we are considering 3 as the intermediate node. So, first, let us write the values of D2. D2, like vertex 1, 2, 3, 4. Here we have vertex 1, 2, 3, 4. And the values are 0, 3, 0, 3, infinity, and 5, and 2, 0, infinity, and 4. We have just calculated previous one. We are just taking that value as the reference here. And this is the 3, 1, 0, 5, infinity, infinity, 2, and 0. This is the value when 2 is the intermediate node. Now let us compute D3 when 3 is considered as the intermediate node. Okay. So let us calculate the value. Let me draw one more matrix here. This matrix, and here we have 4 columns and 3 rows. Four rows and 4 columns because we have 4 vertex. So this is 4 plus 4. 1, 2, 3, 4. 1, 2, 3, 4. This column. Now diagonals are zeros. We'll just keep this as 0. And here we are considering 3 as the intermediate node. So we'll just freeze this vertex 3 in this one. So we'll just put this, this one. we are going to consider 3. So we'll just put 3 row and third column as the phrase. We'll phrase this. So just copy the value 3, 1, 5, and third column is infinity, infinity, 0, 2, infinity, infinity, 0, and 2. Now we need to calculate the values for 1, 2, 1, 4, 2, 1, 2, 4, 4, 1, and 4, 2. Let us calculate these values. So 1, 2, 1, 4, then 2, 1, then 2, 4, and 4, 1, 4, 1, and for 4, 2, 4, 2. So if we are taking 1, 2, so it means here we will consider 3 as the intermediate vertex. So cost will be 1, 2, 3, and then 3 to 2. Here for 1, 4, 1, 2, 3, and then 3 to 4. Similarly, 2, 3, and 3, 1. Here 2, 3, and 3, 4. Here 4, 3, and 3, 1. Here 4, 3, and 3, 2. So we need to calculate these values. Okay. So let us compute these values. If the computed value is less than the existing value, we will definitely update the weight. So 1, 3, we'll see here 1, 3 is infinity. So just write infinity. And if this is infinity, whatever the value is 3, 2, that will be infinity. So it is infinity. 1, 3 in 1, 3 is infinity. So in this case also we'll have infinity. So whenever we are calculating value as the infinity, but 1, 2 is already having 3 values, that is minimum. So we'll consider this value. And 1, 4, we have already 5, and the newly computed value is infinity. So we'll take minimum, that is 5. Now come to 2, 1. So 2 to 3, 2 to 3, we'll see here 2 to 3, that is infinity. So again, it will come infinity. And the previous value 2, 1 is already 2. So we'll copy this value. Now come to 2, 4. So for 2, 4, we have 2 to 3 and 3 to 4. So 2 to 3 is already infinity here also. So there is no change. It will be infinity. And the value, that is existing value of 2, 4 is 4. So we'll take minimum. And now come to 4, 1. So for 4, 1, we'll go 4 to 3. So just see 4 to 3 is 2. So value is 4 to 3 is 2. And 3 to 1, that is 3. So 3 plus 2, that is 5. And the existing value 4 to 1 is infinity. So we'll definitely take this minimum. So we'll update this weight as 5. Now come to 4, 2. So for 4 to 3, we'll see the cost of 4 to 3. So 4 to 3 is 2. And 3 to 2. So 3 to 2 is 1. We'll write 1 here. So 2 plus 1, that is 3. So 4 to 2 is 3. And the existing one is infinity. So we'll take this minimum one. And we'll write this as the 3. So this is D3 that we have calculated, D3. When we consider 3 as the intermediate node, in this case, we have this one is the minimum. So what is the benefit? It means this D3 is having the shortest distance, because we have already covered D1, D2, and D3. So till D3, this is the shortest value. Now only one possibility is there when 4 is the intermediate node. So we need to calculate the value whenever the 4 is the intermediate node. So let us compute D4, value for D4. So let me write D4 also. So let me write here. So we'll create D4. Again, we'll have matrix, 4 plus 4 matrix, 4 rows, because 4 vertices are here. And we'll have 4 column. In this one, we have 4 column. Now let me mark the row number 1, 2, 3, 4, here 1, 2, 3, 4. So diagonal is 0. We'll just copy this diagonal as it is. And we are considering 4 as the intermediate vertex. So we'll just keep 4 as it is. So we'll just copy 4. Cost of 4. That is, we'll just copy this value. Fourth column and fourth row in D3. Okay. So let me write this 5, 4, 5. And here we have 5, 3, and 2. Now we need to calculate only these values, that is 1, 2, 1, 2, 1, 3, 2, 1, 2, 3, 3, 1, and 3, 2. So uh, let me compute the values. We will write values of these. So we need to calculate 1, 2, 1, 3, 1, 2, 1, 3, 2, 1, and 2, 3, then 3, 1, and 3, 2. Okay. So we need to calculate only these 6 values here. So here we are considering 4 as the intermediate vertex. So we will reach first 4, 1 to 4, then 4 to 2. Similarly, we'll write for all these pair 1 to 4 and then 3, 2 to 4, then 1, 2 to 4, then 3, 3 to 4, then 1, 3 to 4, and then 2. So let us see the value of cost of 1 to 4. So 1 to 4 is 5, and 4 to 2, 4 to 2 is 3. So 5 plus 3, that is 8. So 1 to 2 is 8, but existing value is 3. So we'll just write 3, that is the minimum one. For this one, 1 to 3, 1 to 4. What's the cost of 1 to 4? That is 5. And 4 to 3, 4 to 3 is 2. So 5 plus 2, that is 7. So 1 3 is 7, and existing value is infinity. So we'll definitely update this value, that is 7. Okay. Now come to this one, 2 to 1. So for this, we need to calculate 2 to 4 and then 4 to 1. So 2 to 4 is 4, and 4 to 1 is 5. So 5 plus 4, that is 9. So 2, 1 is already having 2 values, so we'll not update, we'll just copy this value, that is 2. Now for 2 to 3, so 2 to 4 is again 4, and 4 to 3, let us see what is the value of 4 to 3. 4 to 3 is 2. So 4 and 2, 4, 2, that is 6. 4 plus 2, that is 6. So let us see what is the cost of 2 to 3. Cost of 2 to 3 is infinity, and we have calculated 6. So definitely we'll update this value. We'll write 6 here. Now come to 3, 1. So for 3, 1, we need to find out 3 to 4 and then 4 to 1. So 3 to 4 is 5, and 4 to 1 is again 5. So 5 plus 5, that is 10. So what is the value of 3 to 1? 3 to 1 is already having 3. So definitely we'll take this minimum one. So we'll write 3. Now come to 3 to 2. So for 3 to 2, we need to calculate 3 to 4 and then 4 to 2. So 3 to 4 is 5, and 4 to 2, 4 to 2 is 3. So 5 plus 3 is 8. And what is 3 to 2? The existing value is 1. So we'll definitely take 1. So now this is the, we can say, this is the final matrix, that is D4. and this denote the shortest path for each pair of vertex. Like diagonal is zero, definitely, because we don't have any self flow. So cost of 1 to 1 is definitely 0, 2 to 2 is 0 and 0. Cost of 1 to 2 is 3. Cost of 1 to 2 is 3. 1 to 3 is 7. 1 to 5. So if we summarize this one, we can write like this: 1 to 2, 1 to 3, 1 to 4. Okay. Now come to 2. Vertex 2 to 1, then 2 to 3, 2 to 4, 2 to 4, or 3 to 1, 3 to 2. Like this, we can write values for all. So this value denotes the shortest distance. Okay. So here, 1 to 2, we have 3, 1 to 3, we have 7, and 1 to 4, we have 5. But 2 to 1, we have 2, 2 to 3, we have 6, 2 to 4, we have 4, 3 to 1, we have 3, 3 to 2, we have 1. Similarly, for 3 to 4, 3 to 4, we have 5. For 4 to 1, we have 5. 4 to 2, we have 3. Similarly, for 4 to 4, 4 to 3, we have 2. So see, these are the all pair shortest distance we have calculated using Warshall's algorithm. So what is the complexity of what will be the complexity of this algorithm? So complexity, if we see, uh, here we have a loop that is for k equals to 1 to n. And within this, what we have a loop for I equals to 1 to n, and for j equals to 1 to n. And here we are calculating some like dij equals to minimum of dij and dik plus dkj. So if we calculate this one, this is the algorithm. So this outer loop will run n times, and these loop will be approximately run n times and n times. So overall, this step will take n cube times. So the worst case complexity of this algorithm will be order of n cube. And this is dynamic programming approach. That's why it is taking n cube times. So applications is very simple. This can be used to connect all stations with every station, all other stations, or we can say one office to all other offices. Or if we are going to connect any network in which we are trying to connect each uh, router with other routers. So in there are many applications of this in the computer science field. These are the references used in this lecture. Thank you for watching this video.